Good day, class. Today's topic is about division of rational algebraic expressions. To divide rational algebraic expressions, first, change the operation to multiplication and get the reciprocal of the divisor. Second, simplify the given if possible. Third, multiply the numerator to the numerator and the denominator to the denominator. And fourth, simplify the product. Let's try this example. 2 over 10 divided by 2 over 3. First, let's just copy 2 over 10. And then we're going to change the operation from division to multiplication. Next, we're going to get the reciprocal of the divisor, which is 2 over 3. And the reciprocal is 3 over 2. Now we have 2 over 10 times 3 over 2. Next, we need to simplify the given. 2 over 10 can be simplified as 1 over 5. And let's just copy the rest since 3 over 2 is already in its simplest form. Now we can proceed to multiplication. Numerator times numerator, that is 1 times 3 is 3. And denominator times the denominator, 5 times 2 is 10. Our final answer, 3 over 10. Let's try another example. 1 over 7 divided by 2 over 5. We're going to copy 1 over 7. Then we're going to change the division to multiplication and get the reciprocal of 2 over 5. And that is 5 over 2. Since everything is in their simplest form, we can now proceed to multiplication. Numerator times numerator, that is 1 times 5 is 5. And denominator times the denominator, 7 times 2 is 14. Our final answer, 5 over 14. Another example, 3 over 4 divided by 6 over 5. Same process. Let's just copy 3 over 4 first. Then change the operation from division to multiplication. And then get the reciprocal of 6 over 5. That is 5 over 6. Now let's try to simplify this given. We have a numerator 3 and a denominator 6. We can simplify these numbers as 1 and 2. And let's just copy the rest. Now we can proceed to multiplication. Numerator times numerator, 1 times 5 is 5. Denominator times denominator, 4 times 2 is 8. Our final answer, 5 over 8. Next example, 6x over 9 divided by 5x over 1. We're going to copy the 6x over 9 first. Then let's change the operation from division to multiplication and get the reciprocal of 5x over 1. That is 1 over 5x. Now let's simplify this. 6 over 9 can be simplified as 2 over 3. And let's just copy the x. And also let's just copy 1 over 5. Now we have 2x over 3 times 1 over 5x. As you can see, we have x on the numerator and x on the denominator. We can cancel those two x's. leaving us with 2 over 3 times 1 over 5. Now we can proceed to multiplication. Numerator times numerator, 2 times 1 is 2. And denominator times the denominator, 3 times 5 is 15. Our final answer, 2 over 15. Let's try another example. 2 over 9y divided by 5y over 2y. We're going to copy 2 over 9y first. And let's change the operation to multiplication and get the reciprocal of 5y over 2y. That is 2y over 5y. Now, since we have a y on the numerator and y on the denominator, we can cancel those two y's, leaving us with 2 over 9y times 2 over 5. Since everything are in their simplest form, we can now proceed to multiplication. Numerator times numerator, 2 times 2 is 4. And denominator times the denominator, 9y times 5 is 45y. That will be our final answer, 4 over 45y. Let's try another example. 14 times the quantity of z plus 3 over 3 divided by 21 times the quantity of z plus 3 over 2. First, we're going to copy 14 times the quantity of z plus 3 over 3. And we're going to change the operation from division to multiplication. And let's get the reciprocal of 21 times the quantity of z plus 3 over 2. And that would be 2 over 21 times the quantity of z plus 3. Now let's simplify. As you can see, we have z plus 3 on the numerator and z plus 3 on the denominator. We can cancel those two z plus 3. And also 14 and 21 can be simplified. That is 2 and 3. And let's just copy the rest. Now we have everything in their simplest form. We can now proceed to multiplication. Numerator times numerator, 2 times 2 is 4. Denominator times the denominator, 3 times 3 is 9. Our final answer, 4 over 9. Another example. 2 over x minus 8 divided by x minus 6 all over 9x minus 54. Let's just copy the 2 over x minus 8, change the operation to multiplication, and get the reciprocal of x minus 6 all over 9x minus 54. And that is 9x minus 54 all over x minus 6. Now let's simplify the given. Here, 9x minus 54 can be simplified. But before that, let's just copy 2 over x minus 8. Now, the simplified form of 9x minus 54 is 9 times the quantity of x minus 6. We use the common monomial factor. And let's just copy x minus 6. Now, as we can see, we have x minus 6 on the numerator and x minus 6 on the denominator. We can cancel those 2x minus 6, leaving us with 2 over x minus 8 times 9 over, since we don't have any denominator, we can write 1, since 9 is equivalent to 9 over 1. Now everything are in their simplest form, we can proceed to multiplication. Numerator times numerator, 2 times 9 is 18. And denominator times denominator, x minus 8 times 1 is x minus 8. Our final answer, 18 over x minus 8. Another example, z squared plus 13z plus 40 all over z plus 5 divided by 10 over z plus 8. Copy z squared plus 13z plus 40 all over z plus 5. Change the operation to multiplication and get the reciprocal of 10 over z plus 8. That is z plus 8 all over 10. Now let's simplify this given. Z squared plus 13z plus 40 is an example of general trinomial. We can simplify this by factoring, and its factored form is quantity of z plus 5 times quantity of z plus 8. And let's just copy the denominator z plus 5. And also, let's just copy z plus 8 all over 10. Now we have z plus 5 on the numerator and z plus 5 on the denominator. We can cancel those. 2z plus 5, leaving us with z plus 8 over, again, since we don't have any denominator, we can write 1. Then copy times z plus 8 all over 10. Now everything are in their simplest form. We can now proceed to multiplication. Numerator times numerator, z plus 8 times z plus 8. Multiplying these binomials, we'll get a perfect square trinomial, which is z squared plus 16z plus 64. And denominator times the denominator, 1 times 10 is 10. Our final answer, z squared plus 16z plus 64 all over 10. And that's how you divide rational algebraic expressions.